Okay, so today our learning goal is to understand the counting principle. So basically what we just did when we listed them all out, that is finding all of your outcomes by making a detailed list. Today I'm going to teach you how to do it without making a detailed list. Now, sometimes you need the list and sometimes you don't. So it just depends on what we're doing. So this first slide, I wanted to put it in something I thought you would understand. And so I put it into clothing options. So let's say that in your closet, you have 2 pairs of jeans that are your ultimate favorite. Like you love them, those are your favorite. And then you have 3 shirts that you love, and you have 2 pairs of shoes that are your favorite. Okay? So the question would be, how many different outfits can you make with your favorite items? And so you could make a detailed list and say, pair of jeans 1 and pair of jeans 2, and then you could put the different shirts and you could put the different shoes. Or you can use the counting principle that says, you have 2 pairs of jeans, you have 3 shirts, you have 2 pairs of shoes. You can multiply these numbers together and get 12, and that is how many outcomes you would have. Okay, you would have 12 different ways that you could wear those favorite items. Okay, now the indigits, they did shapes and colors. So they said you have 2 shapes and you have 3 different colors. Here are the 6 outcomes you can make. You do 2 times 3 is 6. But I thought the outfits would make more sense. All right, so that is counting principle. So the first thing we're going to do is find counting principle if we were having a school election. So when you have school elections, and you'll see this more in high school, you'll have a president, a secretary, and a treasurer. So using the counting principle, let's see how many outcomes we would have. So how many choices are there for president?
2.
There are 2 choices. How many for secretary?
3.
There are 3. And how many for treasurer?
2.
2. So the counting principle says if I take 2 times 3 times 2, there is a total of 2 times 3 is 6 times 2 is 12. There's a total of 12 different outcomes that we can have in this election. Okay? All right. What do we want to put on the first part of our tree? What? President. So our 2 options for president are Martha and Ethan. So I'm just going to use
Hillary and Donald. Okay.
Remember what we talked about yesterday, right? Yeah. Okay. All right. So Martha and Ethan. So M and E. All right. So the next choice, is this next choice independent or dependent?
Dependent.
It's independent because the secretary doesn't matter who got president, right? Doesn't matter. It doesn't matter who. Secretary is its own thing. So how many choices then are there for secretary? There's 3, right? So each of these are going to have 3 branches coming off. Okay, and you're going to have either Ben, Rosa, or Zach. Ben, Rosa, or Zach. Those are all the people who could then be secretary. Okay, so this represents, for just these first 2, there are 6 different outcomes before I even add treasurer. Okay, all right, so now we're going to add treasurer in. How many treasurers are there? 2. So each one of these should have 2 of these coming off like this. Okay, and each one of those would be Andy and Theo. Andy and Theo. Okay, and then I should see a total of 12 different outcomes because that's what we already decided was there, right? All 12 outcomes. Okay, questions on that? Is that helping make more sense with the tree diagrams? The last 2 hours, they're really struggling with making those. It's easy? Well, good. Good, I'm glad. Okay, let's move on to the next part then. All right, I would like you to try to use the counting principle, which is our learning goal today, to figure out this question. So go ahead and try it.
You have them going like all down, and then you'd have mild, medium, spicy, hot, or super hot.
Good, so that's 5, right? So if we're going to use the counting principle, what do I have to do with that 5, the 5 you just said? Multiply by what?
2.
And why 2?
With cheese or without.
Because there's with cheese or without cheese, and that's 2 choices. So you have 5 choices of chili times 2 choices of cheese. So using the counting principle, you have 10 outcomes. If I wanted to list those 10 outcomes, then, which would be the sample space, then I could go ahead and do a detailed list, or I could do a tree diagram, or I could do a table. But all this asks for is how many outcomes. Okay? Yeah, that's all this one asks for. It just said how many different ways can you order chili. It didn't ask for what the different ways were. Okay? All right. Okay, so next part of this, because remember, the ultimate goal is that we're going to be able to find the probability of compound events. So we had to learn how to create a sample space. Now we're going to throw action in there to figure out how do we figure out how many things are happening, or sorry, not action, our event. So the event on this one is toss tails or roll an odd number, okay? So first thing I have to do is say, what is the total sample space? So they've already created a detailed list for you. So here's all of the things that can happen if I toss a coin and roll a standard number cube, okay? So then I say, but specifically, I want to know how many, this event. If I toss a tails, the word or roll, get an odd number. There are 9 outcomes. Tail in 1, tail in 2, tail in 3, tail in 4. There are 9 outcomes within that sample space that would make me win. Okay? If I said the word and instead, would that change it? Yes. So if I said and, then the only ones that would work is this one, this one, this one. I think that's it, isn't it?
Yeah,
If I said and. So I want you to understand the difference between an or statement and an and statement, because that's a big deal. All right, so let's see if we can do that. This is the one from yesterday, so we don't have to do it again. Remember we talked about if you had 3 kids and you have boys and girls in your family, and there was a total of how many outcomes on this tree diagram?
14.
Okay, so we're struggling with how to find the outcome. Okay, so remember we listed all of them yesterday, and we said boy, 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 that would be 1. Boy, boy, girl, that would be 2. Boy, girl, boy, that would be 3. How many are there?
6.
There's 8. You really only have to look at that last column, right, to figure out how many outcomes there are. So there's 8 total outcomes. Okay, so this says what is the number of outcomes? It's 8. There's 8 total outcomes. Okay, now they're going to give you an event. So specifically, they want to know how many times can you get exactly 2 boys. Okay, so now you're going to go through all of the sample space here and figure out when can you get exactly 2 boys. So if I have a boy, boy, and boy, is that exactly 2 boys? No. Boy, boy, girl. Yes. I always circle in that last column when I'm trying to figure this out. All right, what about boy, girl, boy?
Yes.
Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. Girl, girl, girl. How many outcomes are in this event then? 3. There's 3.
Why can't you do like boy, girl, girl?
Because it says you have to have exactly 2 boys. So you can't have 2 girls. All right, so let's do the next event. The next event is get at least 2 girls. Okay, at least. That's a different way to say it. All right, so at least 2 girls. Boy, boy, boy. Boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Yes, that's at least. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. 2 girls, right? At least 2 girls. Girl, girl, boy. That's okay. Girl, girl, girl. Yes, because it says at least 2 girls. If I say I will be happy with my life if I get at least 2 girls, then the last kid I'm saying I don't really care if it's a girl or a boy. I just at least had my 2 girls. Okay? All right, how many outcomes in that event?
4.
There are 4. Good. And how many total outcomes are there? There's 8. It's the same number of total outcomes. It's just the event will change how many you get. Okay? All right. Look at the next one. Okay, if I look at this one, it says you're at a restaurant and you're going to order a 2-course meal. Do you guys understand what a 2-course meal is? Give me, what's an example?
Lunch and dinner. I mean,
No.
dinner and dessert, something with dessert.
Okay, dinner and dessert. That would be an example.
Appetizer and dinner.
Appetizer and dinner. If I had a 3-course meal, that means I might have had either a salad and then my main meal and then a dessert, or an appetizer, main meal, dessert. You could have a 4-course meal. There's 5-course meals. You might have like a soup, a salad, an appetizer, and dessert, and a meal. So all of those, that's the different courses. All right, so this one says that all you want is lasagna for dinner. Okay? And it wants to know, if you only have lasagna, how many different ways can you order a 2-course meal? So think about that. Look at that. How many different ways can you order a 2-course meal? Jake? 5 different ways. Because you can order lasagna and wings, lasagna and salsa, mozzarella sticks, mild wings and hot wings. There's 5 different outcomes in that. Okay? Okay, if you only order lasagna. If you ordered anything else, there'd be a whole bunch of them. All right, we're on to the last one. This is the hardest one we're going to look at, and you have to pay the most attention. All right, this says, how many different ways can Alice, Becky, Carl, and David place first, second, and third in a race? And how many different ways can Alice finish ahead of David? Okay, so it doesn't tell us what to do, but we have to have some kind of organized way to figure out which ways they come in, first, second, third. So what is going to be the best way to figure out, to organize our thought process on this? It's going to be the best way to organize. Remember, we had create a detailed list, tree diagram, table. Those were the ways that we had to organize outcomes.
Are you going to use a table?
Okay, so a table worked with three different things.
No.
The table worked when you had two things, right? One
Tree
was
diagram.
So probably a tree diagram, okay? And this tree diagram is going to get a little lengthy, so we're going to create a new slide. So go ahead and add a new slide in, a new blank slide here. Now what's really nice is all the names are A, B, C, D. So we can literally just work with A, B, C, D. That will really help us. Okay, what's going to go in column 1, the first column on our tree diagram? Okay, and what will that represent?
The names, people.
The what? What about those 4 people? So this would be first, second, third, fourth? You sure? So Alice, Becky, whatever their other 2 names were. What is this? This represents each of them coming in first. Again, this is why I want to do this, so that I can help you with it. So this is saying A came in first, or B came in first, or C came in first, or D came in first. Okay? Now, is this going to be independent or dependent events? Dependent, because each time I go second place, it's dependent on who came in first, right? Okay, so how many limbs am I going to have off of A? 3. Because A can't come in second place, right? A's already come in first. So now I need this right here represents second place. So if A comes in first, who can come in second? B. Who else? And D. Okay? All right, if B comes in first, who can come in second? A, C, or D. See, isn't it nice that they're an A, B, C, D? Makes it a lot easier here. Okay, if C comes in first, who comes in next? A, B, or D, right? The question says, when will A beat D? Okay, so when will A beat D? So I'm going to write that. When does A beat D? Okay, so here's A. A comes in first place right here. What does that mean? Yes, all of those outcomes in this section, A is going to be the winner because it came in first. So there's 1, 2, 3, 4, 5, 6. A will win all 6 of those outcomes. Okay, now let's look at B. So if B takes first, A takes second. So what happens with these 2 outcomes? It's in front of D, right? So it's going to beat both of those because A came in second. So those 2 outcomes. What about B, then C, then A?
A's going to come in third.
A's going to come in third. Where's D going to come in?
Fourth.
Fourth. So A beat D here, right? B, then C, then D. Where did A come in?
Third.
Last. So A does not win there. All right. So what about C, and then, oh, I forgot one. B, then D. What's going to happen with these 2 outcomes if D
A's
comes
going to
in?
come in third.
Yeah, so that's not going to work, right? So
So
none
it's
of
just
those.
the highest letter would come in like the, like, because it's like C, A, and C.
A, and then B. Where's D going to come in on this row?
Fourth.
So that's going to work, right? C, A, D. That works, right? Okay, what about C, B, A? Yeah, because D would be last. C, B, D? No, A is going to come in last. C, D, A. No, because D is in second, so that none of those work. Okay? All right? Yes, to figure out total number of outcomes, you just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 outcomes here where the event A will beat D will work. Okay? So some of these are going to take a lot of side work in order to answer the question. Okay? Any questions on that?